Okay, so to graph an image 90 degrees rotation counterclockwise, what I'm going to do is I'm going to start by putting my compass at the center of my graph, and then I'm going to line up the hole that matches to the point I want to move. I'm going to start with A, so I am going to draw an arc from A. Sorry, my compass is new. Okay. Then what I want to do is I want to draw my line. Counterclockwise is actually the opposite direction, so I want to go back and draw more of my circle. Okay. So I want to draw a line connecting my point from A to the origin. I went too far. And what I want to do is I want to line up my dot. On yours, it's a tick mark, and then the line I want to match up with the compass. And then I'm going to look for 90 degrees. Mine is right here, so I'm going to draw a little dash right there. And then from my origin to that point, I'm going to draw a connecting line. I'm going to mark where they cross. This is my new A prime. I'm going to go do the same thing for my other 3 points. So I'm going to go do B next. Okay. Then I draw my line to the origin through B. Then I grab my protractor and I am going to move it 90 degrees. I put the tick mark at 90. And then I connect the point and the tick mark together. And then where the line and the arc cross is going to be B prime. I'm going to do the same thing for C. Then I draw my point through the origin. Then I go and grab my protractor. I line it up. And then I mark my 90 degrees. And I connect it. Where they cross is my C prime. Then I want to go ahead and connect all 3 points. And I've rotated my triangle 90 degrees around the origin counterclockwise. So like I said earlier, counterclockwise is opposite the way the clock moves. Moving on, it wants me to write a rule of translation, so I am going to count down how many squares and how many over. So it's going 1 down and 3 over. Up and down is Y, left and right is X. So to write my rule, I'm going to write X comma Y, and then translates for that arrow, X plus 3, and then Y minus 1. Okay. Number 3, it wants me to graph this triangle first, so 3, negative 4, 2, 0, and 5, 0. Okay. Then I want to connect to my points. And then it wants me to reflect over the line y equals negative x. So recall the line y equals negative x is a diagonal line that goes down 1 over 1 through, oops, did not mean to move that straight edge, through the origin. Ignore this line. Okay, so if I'm reflecting over this point, what I'm going to do is I'm going to draw my perpendicular lines through the red line. So I line up my tick marks on my ruler or compass or straight edge, whichever has tick marks to line up. So this point of D is going through there, so it's going to reflect because it's half a line away. So this is my new D prime. I'm going to do the same thing for this one is 1, 2.5 triangles away. 1, 2.5. This is my new F prime. And then the same thing for the E. Reflect it over. And then E prime is over here. So actually, let me do this in black so you can see better. Moving on. This one is translating the triangle according to the points up above. It's moving right 2 and up 3. So each of these points is going to go right 2. I don't mean right, I mean left. Minus is left. So they're each going to go left 2 and then up 3. So B is going left 2. 1, 2, 3. Left 2, 1, 2, up 3. 1, 2. Sorry, I did not put this on the graph. A does the same thing. 1, 2, up 3. 1, 2, 3. And those are all my new points. A prime would be, so original A is 2, 4. So I subtract 2 from my point. So it's 0, and I add 3 to my Y, so it's 7. B prime is 0, 4. And C prime is originally 3, 3. So if I subtract 2, it's 1. If I add 3 to my 3, it's 6. Okay. This one wants me to plot the new triangle and say how it's changed from this one. So I'm going right 3, down 3. That's my A prime. I'm going right 3, down 1 for my B prime. And right 5, down 3 for my, should be down 2, for my C prime. Okay. So this one is a reflection, and my line of reflection would be over 1. So it reflects over x equals 1. Okay. On this one, it's talking about a triangle that has points at these points, and it rotates 90 degrees clockwise. So the pattern to this one is, I had 3, 2, 1, 3, 1, 0, and then I rotated 90 degrees clockwise. It would rotate this way. Then I'd go ahead and plot those points again. So I have 1, 2, 3, up to A prime. Okay. Then I do 1, up 3, B prime. 1, not move at all, C prime. So I graph those points and then I figure out where they are now. So start with C prime is at 0, -1. B prime is at 3, -1. And A prime is at 2, -3. So the pattern here is we switch the numbers and then the y values become negative. Okay. This one is talking about a composition transformation. So it's asking me how it goes from the first transformation and then to the second. So from here to here, it's a translation. And it's going down 1, over 1. So left 1, down 1. And then to go from, I ignore the first triangle, from here to here, it's going to reflect. And my line of reflection would be y, or x equals -2. Moving on. This one is saying that Christina thinks this is a congruence transformation of 90 degrees about the origin, and then it reflects across the y-axis. So what I want to do is I actually want to see if this is rotating 90 degrees. So what I want to first do is I am going to rotate my point. Okay. It's not rotated very well. Okay. And then I would draw my perpendicular line. And then I do my protractor. So 90 degrees is right there. It would be right there. And then I reflected the wrong one. I meant to reflect this one. So I'm going to do this in red. Because I didn't read the directions to see which one it went. So it's going 90 degrees from ABC to FGH. So then I draw my perpendicular line. B would go up here. If it reflected, it'd stay there. Good so far. A is on the edge. Okay, draw my line. Then I use my protractor to make my 90 degree mark. And A prime would be here. If it reflected over, it would be right where F is. So she is correct. Okay. On number 9, it's asking me for congruent figures. I'm going to start with this rectangle. Rectangle EFGH is congruent to rectangle VSTU, and it's by a reflection over y equals x. Okay. If I take a look, the two triangles are the same. So I'm going to do triangle JKL is congruent to triangle PQR, and they're congruent by a rotation of 90 degrees. Rotation. Okay. And then if I take a look, my two parallelograms are congruent. So I'm going to do MNNOP is congruent to ABCD. And this one is a translation. So I typically go from the lower alphabetical, or the first letters in the alphabet to the other one. So I am going 1, 2, 3, 4, 5. So I'm going left 5, down 2. So it's a translation. Left 5, down 2. Okay. if I take a look at number 10, it's asking for lines of symmetry. It can only fold once right down the middle, so 1. This one is looking for angles of rotation that will map the hexagon into itself, so how many times I will spin it until it looks the same. So if I start off like this, I can rotate it. Let me put a letter here so I can, or a number so I can keep the figure straight. So it looks the same right now, so that's 2, 3, 4, 5, and 6. So I have 6 rotations. So what I'm going to do is I'm going to do 360 divided by 6, which gives me 60 degrees, and then I start counting by 60. So I have 120, 180, 240, 300, and 360. Once I get to 360, I can stop. Okay? And then my final question is, which transformation is not a rigid motion? This would be a dilation.